Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to everyone. We will start our lecture for CHM475 or CHM477 with introduction, which can be divided into two parts. First is the basic concept of chemical bonding. The second part is the molecular geometry. The reasons to recall the fundamental of chemical bonding is that you studied in your previous chemistry classes are this subject will discuss many topics related to chemical bonding. For example, there are three theories of chemical bonding you will be covered later on, such as valence bond theory, molecular orbital theory, and also crystal field theory. In addition, you will learn the chemical bonding for covalent compounds, metallic materials, and last but not least, the chemical bondings in coordination compounds. Before, I hope each of you will stay focused and try to understand every slide in each chapter. If you have any problems or not understand a particular slide, please do not hesitate to ask me directly. I'm here to make you understand all the contents. First, you should be able to define what is chemical bond. Chemical bond is a strong attractive force that exists between atoms in a molecule. For example, in this compound, there are five, there are seven chemical bonds. All of them are single bonding. One, two, three, four, five, six, and seven. Generally, there are three types of chemical bonds: ionic bond, covalent bond, and also metallic bond. Before we go a bit details about the chemical bonding, please understand the basic of atomic structure. This is the schematic diagram of atomic structure. As you know, the each atom or element in the periodic table containing nucleus that's surrounded by the electrons in different orbitals. The nucleus also is containing of protons plus neutrons. Proton plus neutrons. I want you to understand about the valence electrons. If you heard about what is valence electron, valence electrons are the electrons in outermost orbital. The electrons in the outermost orbital. Remember also the atom in the periodic table can lose or gain valence electrons to become ion. We have two types of ion, cation or anion. Cation is the ion with charge uh, positive. with the charge, sorry, with the charge positive, and anion is the ion with the negative charge. This is positive charge. This is negative charge. Atom also can share valence electrons with another atom to become a molecule. This is the most important point that you have to remember. The valence electrons are used in the formation of chemical bonding. Either the valence electron is transferring, which is loss or gain, or the valence electrons sharing to form the chemical bonds. As I mentioned previously, we have three types of chemical bonds. One of them is ionic bond. Ionic bond is formed by transferring the valence electrons from where to where. Is from metal, normal liquid ion, to non-metal, which is anion. This is the example of ionic compound, which is sodium chloride. Other examples such as magnesium oxide, MgO, and also calcium oxide, CEO. Because in the ionic bonding, the valence electrons is transferring from metal to non-metal. So you have to remember this. In the periodic table, the metals come from group number 1, group number 2, and group number 3 or 13. So group number 1 is +1, group number 2 is +2, group 3 is +3. The nonmetals come from group 15 or group 5, group 16, and also group 17. So this is the charge of the ion, -3, -2, and -1. Next is a briefly explanation about the covalent bond. Covalent bond is formed by sharing. If the ionic bond is transferring the valence electron from metal to non-metal, for the covalent bonds, it is formed by sharing the valence electron between two or more atoms between the non-metal in non-metal. So this is the one example of the covalent compound, which is ammonia, NH3. For your information, for any type of covalent compound, you should be able to identify three things. You should be able to identify which one is the central atom, which one is the bonding, which one is the bonding pair, and which one is the lone pair. Hold on, macam sangkut sikit. Okay, which one is lone pair? So normally the central atom is the less number of metal compared to other atoms. Bonding pair is a pair of sheet valence electron. We call it bonding pair. So for in this ammonia, this is the bonding pair, the first bonding pair, the second bonding pair, and the third bonding pair. For ammonia, they have three bonding pair, which is 6 valence electron. What is lone pair? Lone pair is a pair of unshipped valence electron, or a pair of valence electrons that not involved in bonding. So another terminology for lone pair, we can call it non-bonding pair. This one is bonding pair, valence electron sharing. Non-bonding pair is a pair of electron does not involve in the bonding formation. So for this particular example, which is ammonia, we can say the central atom is nitrogen. The ammonia contains 3 bonding pair, 1 pair, second pair, and third pair, and 1 lone pair, or 1 non-bonding pair. So the next slide is a little bit about the Lewis symbol. Lewis symbol is showing the valence electrons of a particular atom and tracking them in the bonding formation. The elements or the atom in the same group will have the same number of valence electrons. For example, group number 1 from hydrogen up to Fr is only have 1 valence electron because it's a group 1. If a group 2, they have 2 valence electron. Group 3, they have 3 valence electron, and so on and so forth. Group 5, 5 valence electron. Group 6, 6 valence electron. Group 7, 7 valence electrons. So no need to remember this. Just understand group 1, how many valence electron. Group 2, how many valence electron. Group 3, group 4, group 5, 6, and 7. Just remember how many valence electron. Again, same group, same number of valence electron. Okay. Another concept that you have to understand in this chapter, in the basic concept of chemical bonding, is the octet rule. I believe most of you already heard what is the octet all about when you did your SPM, you did your diploma, or you did your matriculation. The octet rule is stated that when atoms bonded, they tend to lose, they tend to gain, or they tend to share their valence electron until the atoms are surrounded by 8 valence electrons. So this is the example of octet rule for chlorine. We know chlorine, Cl2, the chlorines come from group 7. So chlorine has 7 valence electron. This 7th valence electron is also 7th valence electron. In order to achieve the octet rule, or 8 valence electron, this 7 must share 1 valence electron from another atom to become it 8. 7 plus 1, it become it 8. Same goes to the second electron, second chlorine. It is 7 valence electron shared with one another valence electron from another chlorine in order to become 8. So this is the Lewis symbol. This one share one valence electron. This one share one valence electron. If they are sharing with two, 1 plus 1 is 2 valence electrons. This is 2 valence electrons. So it is a single bond. If it is 4, it is double. If they are sharing in total of 6 valence electron, this one is become triple. However, for this particular example, which is Cl2, is only single bonds because it's only share one valence electron from each chlorine in order to achieve the octet rule or 8 valence electron. So we can draw or we can write the distribution of valence electron around the chlorine like this, or another presentation like this, Cl a single bond with Cl. Another example is oxygen. We know oxygen is come from group number 6. It has 6 valence electron. In order to achieve 8 valence electron, the 6 must share another 2 valence electrons from the neighbor in order to achieve 8. And also the second oxygen also share another 2 electrons from the first oxygen in order to become 8. So this one share 2, this one share 2. As you can see, they are sharing in total of 4 valence electrons. So it's meant that in oxygen, the bonding that connected between the two oxygen atoms are double bonding. Okay, if we want to know, this is one bonding pair, and they have 1, 2, 3, 4, 4 lone pair. This one is one bonding pair with 1, 2, 3, 4, 5, 6 lone pair. Again, this is 1, 2, 3, 4, 4 lone pair. This is one bonding pair. Even though it's double or a triple bonds, we consider it one bonding pair. So this why this single is one bonding pair, this double also one bonding pair. Okay, moving forward to drawing the Lewis structure. This is a very crucial topic that you have to understand. You should understand or you should know how to draw the Lewis structure for ionic compounds as well as for the covalent compound. In this slide, we have lithium chloride is the first example of ionic compound. As you know, lithium is from group 1, so it has one valence electron. Because this is a ionic compound, the lithium will transfer its valence electron into non-metal. In this case, is a chlorine. Chlorine is from group 7. It has a 7th valence electron. So because of its 7, when it receives one valence electron from the lithium, it becomes 8. So you can see the valence electrons transfer from the lithium into the chlorine. So in order to draw the Lewis structure for this lithium chloride, you have to put the ions, the positive ion and the negative ion in bracket. The lithium, because it's transfer one electron, it becomes lithium bracket plus, lithium plus, and the chlorine it become negative because it's received another one more electron. So this is the red dot is the valence electron from the lithium. The lithium lose the electron, it become lithium positive. The chlorine gain one additional electron from the lithium, it become ion negative. Okay, another example of magnesium oxide. We know magnesium is from group 2. It has two valence electrons. In oxygen from group 6, it has 6 valence electrons. So by right, you can understand since this is 2, this is 6. In order to achieve the octet rule, it should be transfer two valence electron from magnesium into oxygen to become 8 valence electron. So this is the way to draw the Lewis structure for the magnesium oxide. Because of the magnesium oxide transfer its valence electron into the oxygen, two valence electron, so magnesium oxide become 2 plus. So since oxygens are receiving or again another two additional of valence electron from the magnesium, the oxygens become 2 minus. So this is the way, or this is how you draw the Lewis structure for the ionic compounds. Please showing the transferring of the valence electron from metal to non-metal and produce the positive ion and also the negative ion. The atom in the negative ion, you should show the distribution of the valence electron surrounding it. Okay, next is the procedure or the steps to draw the Lewis structure for covalent compound. It is a slightly different when you compare with the way to draw the Lewis structure of ionic structure. Sorry, ionic compounds. Don't need to worry. You just follow the step. You just follow the following step in order to draw the Lewis structure for the covalent compound. Okay, before draw any Lewis structure, you should be can tell the compound given to you. You can tell is the compound is ionic or the compound is covalent. When you are confirmed it is covalent, so you just follow this procedure. For the covalent compound, in order to draw the Lewis structure, you have to calculate the total number of valence electrons for all atoms in a molecule. Calculate the total number of valence electrons for all atoms in a molecule. Later on, I will show you how to draw, how to calculate the Lewis structure for the covalent compound. Now you just read what is the step involved in drawing the Lewis structure for covalent compound. Again, first, calculate the total number of valence electrons for all atoms in a molecule. Second one, you have to write the symbol for each atom. Identify which atom is the central atom. Connect the atoms with single bonding or with two valence electrons. Third, try to complete the octet rule for the atoms bonded to the central atom. The any leftover valence electrons, you can place it on the central atom. If the central atom, after you calculate the number of valence electron around the central atoms, if you found the valence electron is not enough to achieve the octet, which is 8 valence electron, you have to try to change from single bond to multiple bonds. Multiple bonds meaning that double bonds or triple bonds. Okay, I show you a few examples how to draw the Lewis structure of covalent compound by follow the procedure that we discussed just now. Let's say we have water. Water is H2O. Sorry, my handwriting on the slide is not good. So the first step is you have to calculate the total number of valence electron for all atoms in this molecule. We know in this water molecule we have 2 hydrogen and also 1 oxygen. So the valence electron for hydrogen is 1, and then plus another 1 because it's 2 hydrogen. So it's 1 valence electron, 1 valence electron, and then we plus with valence electron of oxygen, which is 6. So the total number of valence electrons for all atoms in this molecule is 8. Okay. 8 valence electron. Okay, sorry for this line. Okay, it's 8 valence electron. So now you have to write the symbol and try to connect the atoms to this central atom. So for this water, we know the central is oxygen, and then the atom around the oxygen it should be hydrogen and hydrogen. Okay. So you have to connect this central atom with the terminal atom by using first one single bond. One single bond is 2 valence electrons. So one valence electron, one valence electron. So we already use 2, and then another one, another one. So in total we use 4. 1, 2, 3, 4. So 8 minus 4, we have another 4 that not used yet in the formation of Lewis structure. So we have to distribute this 4 leftover valence electron. So we check the octet role for the terminal atom. Terminal atom, this is the central, this is the terminal atom. Terminal atom is the atom connected into the central. As we know, hydrogen is nothing much that we can do because it's only one, so it's impossible to get octet role to achieve 8 valence electron. So it's already full. It's hydrogen's 1, and this hydrogen also cannot achieve octet, so it is maximum 1. Okay, so it's meant that this 4 valence electron, we have to distribute it on the central atom. So since it's 4, so automatically we know they have 2 lone pair. So 1, 2, 3, 4. So 4 minus 4 is 0. So it's mean that we use all the total valence electron. Okay, so this one is mean that this oxygen is connected with single bonding. Sorry, just ignore this one. And this oxygen is connected with single bonding with hydrogen and another single with hydrogen. And the water molecule has two lone pair. Okay. So in the water molecule, we have two bonding pair and two lone pair with oxygen is the central. Okay. We try another example. Let's say we have nitrogen, N2. We know nitrogen is come from group number 5. So the total number of valence electron is 5 plus 5. So kita ada, we have 10 total number of valence electron. So now we write the symbol and we try to connect from one atom to another. I don't like this. We try to connect from one atom to another atom. Okay, as you remember, we try to connect the one atom to another atom with single bonding or two electron, and then already use 2, so 10 minus 2 is 8. Now we have to distribute this leftover of valence electron around the terminal. In this case, we don't have a central atom, so both are terminal atom because it's only two atoms. So we try to distribute this 8 valence electron in order for each nitrogen to achieve octet role, 8 valence electron. So this nitrogen is already has 2 valence electron, so it has another 2, another 2, and another 2. So this nitrogen is already enough 8 valence electron around it. 2, 4, 6, 7. This 2 is this one. So we already use 2, 4, 6. So 8 minus 6. So we have another 2. So since this one is already fully occupied with the 8 valence electron, this another 2 electron we can put it here. But the problem is the second nitrogen don't have enough valence electron to achieve the octet role. It only has 2, 4. So it not enough another 4. So it's meant that we should share another 4. This one, these two should be shared to become double bonding, and this one, it should be shared to become triple bonding. So now we can draw nitrogen. We have 1, 2, 3 nitrogen with another lone pair with 1 lone pair. So we can write nitrogen 1, 2, 3 nitrogen. So this one. So for this particular nitrogen, we have two lone pair and one bonding pair. Even though it's a triple, but we call it one bonding pair. So, yeah, we already followed the procedure that we learned in the previous slide, but I have another way to draw the Lewis structure. It's more easily compared to the previous slide. So no need to remember the step. That one is very optional. You can follow if you wish, or you just ignore if you found it it's a very difficult to understand, and then you just stay with the follow the procedure given on the slide number 9. So this is my way. This is my own way. Okay, nitrogen. We know nitrogens. Each nitrogen has 5 valence electron. In order to become 8, this 5 became 8. This 5 became 8. It should be receive another 3. It should be share another 3. So it means that this nitrogen, they have to share 3 electron with the next nitrogen with 3 electron. So this is already 3 because it's 5. So they have 1 extra and they have 2 extra valence electrons. Same goes to this one. They share 3 valence electrons, so the leftover are 5 minus 3, so have 2. It's the same. So nitrogen triple, nitrogen 1 lone pair, 2 lone pair. Okay, maybe I give you another example. For example, this one, C or 2. We know carbon is 4, oxygen is 6, another oxygen is 6. In this carbon dioxide, we know carbon is the central atom, oxygen will be the terminal atom. So we have another oxygen on the right and another oxygen on the left. Because we know oxygen is a 6 valence electron, so it needs another 2 in order to achieve 8. So it means that they have to share 2 electron. This one also have to share with 2 electron. So they have to share the 2 electron with the carbon. Carbon has to provide another 2. 2, 2. So it becomes double. Same goes to this one. This is a 2 valence electron. So the carbon also have to supply another 2. So the carbon, since we know the carbon is a 4 valence electron, so it's already fully used. Carbon, they have 1, 2, 3, 4. The oxygen, we know oxygen is a 6, so we have another 2. 2, 4, 6. 2, 4, 6. So this CO2 is a C double bond O and C double bond O with 2 lone pair and with another 2 lone pair. Okay. if you find this methodology or this method or this procedure is a bit difficult to understand, you just follow the procedure that given on the slide number 9. Calculate the total number of valence electron, write the symbol for the atom and connect them with two valence electron, and then try to complete the octet for the atoms bonded to the central atom or the terminal atom. And then wherever the leftover valence electron, you have to distribute it or place it on the central atom. And then if you find out the central atom is not enough of 8 valence electron, you just try the multiple bondings, the double or the triple. The double or triple. Okay, so this is the another example of covalent compound. We have CCl4. It's a very easy. Carbon is 4, chlorine is 7. So it's meant that this carbon, this chlorine need 1 electron from the carbon. This is why carbon share 1 electron with each carbon. So this share 1, this share 1, this one is share 1, that's one share 1 valence electron. So this is the Lewis structure of the CCl4. HCl, hydrochloric acid, chlorine need 1 electron to be shared with the hydrogen in order to become 8 or the octet rule. H2O we already covered. The H2 is a very simple molecule. So each hydrogen only share 1 valence electron with another hydrogen. So hydrogen is hydrogen, single bond hydrogen. Okay, so I think we already covered this one. You try to write the Lewis structure for this example of covalent compound. We have water, you have to draw by yourself, you have to try. We have a CO2, you have to do the Lewis structure, and also we have nitrogen, you have to draw the Lewis structure. By trying, by drawing the Lewis structure by yourself, you can observe the formation of single bonding, the formation of double bonds in the CO2, and also the triple bonds for the nitrogen in 2. Okay, this is another type of bonding. We have ionic, we have covalent, and also we have metallic. But this is another additional knowledge or additional knowledge. We call it dative bond. So what is dative bond? Usually we found the dative bond in coordination compound. Coordination compound we will learn in the chapter number 5 onwards. So in the coordination compound, we a lot discuss about the dative bond or coordination bond. Dative bond can call coordination bond. So what is dative bond? Dative bond is a bond where the both valence electron in the bonding pair are supplied by one of the bonded atom. So only a few cases in the ionic compound or covalent compound have dative bond. So this is one of the example which is ammonium ion NH4+. If you try to draw the Lewis structure of ammonium ion, you can see the ammonia. It contains one lone pair. We have 3 bonding pair, and then it has one lone pair. two unpaired valence electron. So in order to form the ammonium, these two unpaired electrons or this one lone pair have to share with the hydrogen. So these two will form the single bonding. The two electrons, the two valence electron from the ammonia will be supplied into the hydrogen. So when we found in this case, we call it a dative bonding. So this is a single bond, this is single bond, this is single bond, this is single, but they have a special terms. We call it dative bond or coordination bond. So because both electrons in the bonding pair are supplied by one of the bonded atom. So the dative bond is represented by the arrow, which pointing from the donor. So this ammonia is the donor, donate two valence electron to acceptor. So the hydrogen accept the two unpaired valence electrons. So only compounds or ions that contain lone pairs are possible to forming the dative bonds. This is for the ionic or the covalent compound. However, for the coordination compound, most of the cases, the bonding in the coordination compound, we call it dative bond or coordination bonds. Okay, we almost finished this chapter. So a little bit information regarding the bond length and also bond strength. So what is the bond length? Length is the distance between the nuclei of the atoms involved in the covalent bond. So this is the nucleus. This is the nucleus, the distance between the nuclei. We call it bond length. Bond length, bond length, another bond length, another bond length. However, no need to worry. No need to remember this value. As long as you know the bond length is the distance between two nucleus or two nuclei of the atom that involved in the covalent bond. Okay, next is the strength. What is the bond strength? The bond strength of covalent bonds between the two atoms is measured in terms of bond enthalpy. Bond enthalpy is delta H. You will learn the enthalpy or the delta H in the physical chemistry. So the bond enthalpy is the amount of energy required to break off the bonding. So the strength of the bonding will determine the stability of the molecule. Is for me is enough if you understand what is the bond length, the distance between what and what is the strength, is the bond enthalpy. So just remember this one, the comparison in terms of length or in terms of strength between the single bond, double bond, and triple bond. So normally a single bond, the we call it the analogy that I also always use in the class. Single bond is like a skinny people, skinny. Skinny is mean that orang yang kurus lah kan. So just analogy, a single bond is a skinny. Double bond is a bit fat. Person, or the triple bond is the fattest one, the fat one. Okay, so when you compare the single, the double, the triple in terms of length, the single is normally is long, but the triple is should be the shortest. This is why we find out the tallest the tall person normally, the skinny person normally is tall, the fat person normally a bit shorter. So this is my analogy, don't hard feeling. So increasing the number of bonding, single, double, and triple, the length decrease. The longest reduce in terms of length in the shortest. So in terms of strength, from single, double, and triple, it's increasing. So normally, the person with have tall height is a very weak. When you push it down, it's a very easy to push the skinny person. It's compared to the fat, the triple person, the triple bonding. So it means that the single is the weakest one, and the triple is the strongest one. So it's a conclusion from single bonding, double bonding into the triple bonding. In terms of length, the length decreasing, the strength increasing. Okay. All right. This is the last slide. Even though we are discuss a lot about the octet rule, some of the covalent compounds still do not obey. Do not obey is mean that do not follow the octet rule. It means that they have the exception to the octet rule. So the octet rule, we call it incomplete. Incomplete maksudnya adalah the number of valence electrons is less than 8 around the central atom. When it expanded is more than 8 valence electron around the central atom. The last one is odd, the odd number of valence electrons around the central atom. This is the example of the the covalent compound categorized is in complete octet. This one is for the expanded, this one is for the odd. So you can try, just pick each one compound, one, just choose either one, and then try to draw the Lewis structure for this incomplete octet, expanded octet, and also the odd octet. I think is enough for the this chapter. As long as you can understand, I just recap what we learned today. As I said, why we study the basic concept of chemical bonding, because in this syllabus, we will talking a lot about the chemical bonding in terms of three theories, and also the chemical bonding in the covalent, metallic, and also the coordination compound. So as long as you can define what is the chemical bond is enough, and then you try to remember we have three types of chemical bonds: ionic, covalent, and metallic. So this is the basic structure of atomic structure. At least you know the most important point is the valence electron. When later on, when I say valence electron, you can imagine or you can understand the valence electron are the electron in the outermost orbital. So these valence electrons used in the formation of chemical bonding. So try to understand how the formation of ionic bonding, try to understand the formation of covalent bond, identify the central atom, bonding pair, and lone pair, and what is the Lewis symbol, what is the octet rule. Spend some time to understand what is the octet rule, and then how to draw the Lewis structure for the ionic compound, how to draw the Lewis structure of the covalent compound. Either you use follow this step, or you use my technique if you wish. Is up to you. And then this is a few example of covalent compound. Please try to draw the Lewis structure for this example. Try to observe the formation of single, double, and triple. And this is another additional information, additive bonding ataupun coordination bonding. Normally, the bonds that used in the coordination compound. And this is additional knowledge, I think, in terms of length, in terms of strength. Try to remember the comparison between the single, double, and triple in terms of length and strength. Length decreases, strength increases, and the exception of the octet-row. So I think it is enough for today. Thank you for watching and listening. See you on the next lecture. Assalamualaikum warahmatullahi wabarakatuh. And bye bye.